Okay, another topic that you're going to see in homework. You're going to have a graph and be one of your basic function graphs. You can actually pick which one you want, but you take a basic function graph and see if this graph matches the shape of the pendulum graph. Now, I just drew a graph up here. Okay, I don't know what function that corresponds to. Actually, I've got a pretty good idea looking at it, but okay. Does the shape of this graph match the shape of the pendulum graph? Well, let's say our pendulum data, which would be something like this. Okay, pendulum length 1, we got a count of 60. Pendulum of length 1/2, the count was 78. Pendulum of length 1/4, the count was, let's say, 110. Okay, that might or might not be very realistic, but could be something like this. Okay, you got your own count, you have your own data, you have your own graph. Can the shape of this graph match this data? Well, it's easy to find out. Let's take a point in the middle of the data and a point in the middle of the graph and just say, okay, this point here is going to be 1/2 78. Well, that means that this is 78 on the x-axis. No, it isn't. This is 1/2 on the x-axis. Don't let me do that. And this is 78 on the y-axis. Once I've got that, I can scale the whole graph, can't I? Okay, so if 1/2 is here, well, I got to go twice that far to get 1, and half that far to get 1/4. Now 78 is pretty close to 80, so I'm going to scale this axis. I'm going to say, okay, here's 80. So I'll write the 80 here. And if I subdivide that, divide 80 in half, I get 40. Now, write things over here. Divide that in half, I've got 20. Halfway between here and here is 60. And then, of course, I can do another 80 up here. I can get 160 up here. Divide this interval in half, and I've got 120. Divide this in half, and I've got 100. And then here's going to be 110. Here's going to be 90. Here's going to be 70, here's going to be 50, and so forth. Okay, so now I've got a pretty consistent scale. Now that's not a great scale because my interval here is of 20 is a lot bigger than my interval here. It looks like maybe my 160 should have been a little higher. So there are things that could have been done more carefully, and you try to do them more carefully. The principle is going to be the same either way. So let's see. Now I want to look at what this shape of the graph predicts to be the count or the frequency corresponding to 1 unit. So if I come up here to the graph and project over here, I find that the coordinates of this point came out a little high. I'm going to say that's pretty close to 130. That's not good. Okay, it tells me right away that the shape of this graph isn't going to work. Now maybe if I move the 1/2 over this way or this way, we can make it work a little better, but probably not. And if this is the shape of one of your basic graphs, it's not going to, if it doesn't work one place, it's not going to work another. And if it works one place, it'll work another. Okay, and we need to maybe prove that, but that gets a little deep, so we're not going to worry about it now. Does 1/4 correspond to 110? Well, if I come up from 1/4 and try to keep this honest, let's see where I end up. It doesn't do quite as bad on 1/4. It looks like that's maybe around 130. Okay, but clearly this graph does not fit and pretty much can't be fit no matter where I try to put these points to the pendulum data. And if I graph the pendulum data, of course 160 should be, well, here's 60, here's 1, so I should have the point 160 maybe about here, maybe a little lower. I didn't want to get into the green there. And 1/4, 110. It doesn't work real well. Now what I ask you to do for the homework is do the graph of the basic reciprocal function. So you're going to have 2, you're going to have 1, you're going to have 1/2. And out here you're going to have 2, 1, 1/2, and you're going to have a point here, and a point here, and a point here, and you're going to have a curve that at least goes to here. Okay, now the curve goes on up, and we haven't talked about the details of that, but we will. And the point I ask you to relabel is the point 1, 1. And that is the point that for this data you'd relabel as 1/2 78. And then we go ahead and relabel the axis down here. 1 becomes 2. Sorry, 1 becomes 1/2. And then 2 is going to become what? 2 is going to have to become 1, isn't it? And 1/2, well, you figure out what 1/2 is going to become. And the 1 here is now going to become 78, because this is the point 1/2 78 on the labeling. Got to have 1/2 here, and we got to have 78 here. So this is going to become something. This is going to become half of 78. That's going to be 39. I'll let you figure out what number goes here and what number goes here. You relabel it and do the same thing I did and see if it works. And then maybe you go to the reciprocal square and see if that works. Or maybe you relabel the basic squaring function, which I'll just kind of sketch here, to show you that the relabeling would take this part of the graph. We're not interested in this part because the pendulum doesn't do this. Pendulum does this. Okay, so we maybe highlight this part of the graph and then just draw a squiggly line through this one. We don't want it anymore. Then we relabel some point over here. Maybe we just relabel it. Maybe we put 0 here, and we put, yeah, let's not put 0 there. Let's put 0 here and 1 here on the relabeling. So I'll do the relabeling in orange. 0, 1. Okay. Then 1/2. Yeah, let's put 0 over here. Gives us more room. Okay, so we take, let's say, this point here and label it 1/2 78. This point's 1. Actually, that probably wasn't a good idea because that goes all the way down to 0, doesn't it? So maybe we relabel it a little differently. Maybe we put 0 here and 1 here and make a bigger graph. Now we've got just this section of the graph corresponds to our pendulum. Okay, so maybe even for present purposes, eliminate those points. Okay, then we see if we can relabel a section of this graph so that it matches this data. Okay, it might actually even be possible to do that at some point of this graph. We do a little algebra and figure it out. So that's the basic idea. Is there a part of a basic graph that can be relabeled to match the pendulum graph? It's going to turn out that none of those functions really can be relabeled, although we might find a section of this one that works for 3 points that won't work for the other point. It's got to be a different function, but we can build a different function that does match pendulum data very well and matches it exactly in a theoretical sense, just out of a composite of a couple of basic functions. And we'll get to that, but it'll take us a few days to get there.